Hi, everybody. This is Calabrese here. Today is Monday, April 6th, and this is your very next math lesson. Congratulations. A couple of reminders before we start. Make sure you have paper and a pencil. I've got a pen today to try to make my work show up a little bit darker on the screen, but try to find a pencil that you can use at home for math today, and make sure you're in a space that is both quiet and focused. Let's go ahead and set up our notes. Today is 4/6. These are math notes. Just a reminder on your organization, we're entering week 2 of class. We're switching topics a little bit, building on what we learned last week. It's still important that you keep all of your notes so that you're prepared and you have those resources for yourself as you continue forward. So again, make sure after this lesson that these notes end up stored in the same place and organized with all of your other notes. Really excited because this week we're going to focus on simplifying expressions. I'm excited because there's a lot of built-in skills here that are really excellent to practice as we prepare for next school year and the rest of this school year. Today we're going to focus, since it's our first day, focus on using really precise vocabulary. So I'm going to do my best to model that during the video. We're going to start with just a quick review of some vocab. The first word that I want to review is the word variable. Go ahead and take notes with me. The word variable is one we use a lot. Let's go ahead and define it. Variable is a letter that stands for a number. It has the value of a number. So that's what I'm going to write. It is a letter that stands in and has the value of some number. I'm going to read it one more time. If you need more time to write, feel free to pause the video. Variable is a letter that stands in and has the value of some number. So we see variables in expressions, we see variables in equations. When we do that, we typically want to solve for the value of the variable. But when we're talking about expressions, we're not necessarily looking for the value of the variable unless we're explicitly asked to evaluate. Awesome, let's move on. Do you remember the word coefficient? I hope so. Check that spelling. The coefficient is the number that is right next to the variable and that's being multiplied to the variable. So it's part of the variable term. This is the number that is multiplied to the variable. Okay, so let's just write a quick example. A variable term like 3x has two little parts in this one term. This 3 is called the coefficient. Go ahead and label it with me. And we know this x is called variable. Okay. There's one other word that's implied in here, and I think I've actually used it. And that is the word term. The whole thing together is called a term. T-E-R-M. So let's go ahead and define term. A term is any product or any value that is being added or subtracted within an expression. So parts, I'm going to write parts of an expression that are added and subtracted. Parts of an expression that are being, move up my paper, sorry team, that are being added and subtracted. Okay. So let's write an expression really quick. How about negative 2y plus 6 minus 4w? I'm looking at the different parts of the expression overall that are being added and subtracted, and I see 1, 2, 3 parts that are being added or subtracted. There are 3 terms in this expression. Okay. I'm going to go ahead and label that. This one has 3 terms. This is great practice. There's a question like this in your independent practice today. In my other expression, I wrote 3x. How many terms are here? Remember, terms are parts of an expression that are being added and subtracted. This is only one term. There's nothing else being added or subtracted from it, just 3 times x or 3x. One term expression there. All right, and then the last vocab word that I want to write down is constant. And this is a term that with no variables. A term with no variables. So you can think about this term as not the product between a variable and a number, but just the number. So in this expression, the constant term is 6. Okay. All right. One thing that you'll be asked to do today and this week is to combine like terms. So let's go ahead and I think I said that was our last example, but actually we have one more. This will be our last one. They're really important. I'm really glad I didn't forget it. Like terms are ones that we can combine together. Like terms have the same variable and the same power. So let's give an example with powers. How about negative 3x squared plus 2x squared plus 4x minus 10. If the instruction said combine like terms, the first thing I do is find which of these are the like terms. Now I see that this term and this term have the same variable and the same power squared. There are no other terms that have the same variable and the same power. Okay. Another kind of term is just x, that's to the first power. It doesn't have any like terms in the expression, so I can't combine that one with anything. And then this one, negative 10, or subtract 10, but I think about it as adding a negative 10. There are not any other terms that have no variable, so it doesn't have any like terms either. But when I combine these like terms, I just add their coefficients up. So negative 3 plus 2 is negative 1. Negative 1 x squared plus my 4x minus my 10. That's my simplified expression. I've combined like terms. That's it. Okay. Hopefully that was a good review. Let's start with some practice. Okay. Here is question number 1. Go ahead and put a number 1 on your paper. I want you to read the question and pick your answer. I'm going to put, let me find my timer. I'm going to put just 30 seconds on the clock for you to do that. Go ahead. All right, hopefully you were able to choose an answer. The correct answer is D5N. Nice job if you got it. I do want to show you, I do want to show you my thinking. 5 times N I'm just translating, I think it said 5 times a number n. That just means the variable. Remember, a variable is a letter that stands in and has the value of a number. So we often call it a number n or a number x. 5 times n, remember I can write it as 5n. My coefficient is 5, and n is called my variable. This correct answer was D. What if this question didn't say 5 times n? What if it said 5 divided by n? What would you write for 5 divided by n? You could write that in two ways. 5 divided by n with an old school, elementary school division sign, or you could write 5 divided by n with a fraction bar. We know that fraction bar is division 2. What if it said 5 less than n? What would you write if it said 5 less than n? 5 less than n is n take away 5. So when I see 5 less than n, I write n minus 5. Okay. Common mistake here is to accidentally swap the order here and say 5 minus n. 5 minus n would be n less than 5. So be really careful when subtraction, if you're given in this language, you've got to switch the order up. So don't get tricked in your independent practice today. Let's move on to question 2. For question 2, I want you to read it and try it. I'm going to put 2 minutes on the clock. You may get started. Don't forget your PO code and your explanation. We'll come back together in 1 minute and 40 seconds. Last 35 seconds. All right, pause here if you didn't have time to finish up, and then hit play when you're ready. I selected A and B, so let me know if you got that. I want to just show you my thinking. I don't want to review it too much. A was true because there are, oops, 1, 2, 3, 4, 5 terms being added together. You could call these parts of the expression, similar to a sentence. There are parts of the sentence that are called different things. In math, the parts of the expression are called different things. So these 5 parts are being added or subtracted. There are 5 terms. Okay. You also needed to know that the coefficient was the numbers being multiplied to variables. So the coefficient 4 and the coefficient 8, or even better, -4 and 8. Okay. All right, let's try the next one. Here's question 3. You just need 30 seconds to choose your answer. Please begin. All right. Did you select B? Awesome. Here's what my work looked like. Feel free to update your paper if you didn't get your work on your paper all the way yet. For number 3, I just rewrote the expression. I labeled this one the constant because it has no variable. That was answer choice B. Okay, let's get set up for question 4. All right, question 4. Combine like terms to determine which expression is equivalent to, wow, that's a long expression. Okay, we got this. Taking a look at my answer choices, I see they're all totally simplified. I've got different numbers of t's happening here, and I've got different constant terms. Also notice the order is swapped around a little bit. Good to know. Let's see. Let's actually do this one together. Okay, so I'm going to go ahead, take a second, and copy down this expression onto your paper. I'm going to do that now too. So this is number 4. All right. So here is the expression just copied from the problem. I'm going to simplify it completely. The reason I want to do it together is because I want to take the opportunity to write out what are the steps if the question asks me to simplify an expression by combining like terms. So the first thing I'm going to do, what I did in this step, is copy on my paper. We just did that. The second thing I'm going to do, and I'm going to skip lines so my notes are really clear. Feel free to do that too if you'd like. The second thing I'm going to do is I'm going to actually change all of the subtraction into addition of the opposite, so plus a negative, okay? We call that add the opposite, or we call it change subtraction to addition, or we say keep, change, change, okay? So I'm going to write change, I'm just going to put a minus, 2 plus a negative, okay? So let's see, keep 12, keep plus, keep 5t. Here's subtraction. Change subtraction to plus, and change 4 to negative 4. Okay. This is what we practiced last week, so hopefully things are coming full circle here. Plus 15t plus 1. All right, that got a little messy, sorry. Okay, the third thing that I'm going to do is I'm going to move like terms next to each other. Move like terms together. So remember, like terms, let me go back to my definition. Like terms have the same variable to the same power, okay? So here, there are no powers in this that are written. They're all to the power of 1. We just don't write that. But I do see that some of these are constant terms and some of them are variable terms. All of the variable terms have the same variable t. So 5t and 15t are like terms. I'm going to put a box around the variable terms, 5t and 15t. And I'm going to put more like a cloud shape around my constant terms, 12, negative 4, and 1. So I'm going to go ahead and move the like terms next to each other. I can do this because I have only addition throughout my expression. So an addition is commutative. I can change its order without changing the value of the expression. So I'm going to go ahead and move the variable terms together. So 5t plus 15t. And then I'm going to put all of the constant terms together. Plus 12, plus negative 4, plus 1. I think it's really helpful if you have highlighters or colored pencils to color code these two. That could be really helpful. And step 4, I'm going to combine like terms. Hopefully these steps are helpful. You should let me know in your lesson summary comment if you think this is helpful to have the steps. So let's go ahead and combine 5t and 15t. That's 20t. When I add, or when I combine like terms, I add their coefficients. So this is a group of 5t's and this is a group of 15t's. All together, I now have one big group of 20t's. Plus 12 plus negative 4 plus 1. I'm going to continue combining like terms. I keep my 20t the same now, but I know that 12 plus negative 4 is 8, and I still have that plus 1. One last step, I'm going to add the 8 and 1, combine the final like terms, 20t plus 9. Sweet. Okay, let's just double check what the question says. So we got 20t plus 9. Do you see that? Yep, I see it here. The order is different, but remember that addition is commutative. So 20t plus 9 is equivalent to 9 plus 20t. So the answer is B. Okay. All right, folks, last one. For question 5, I'm going to give you 2 minutes to select your answers. Remember to use process of elimination on your paper as you are working. 2 minutes start now. Alright, I didn't quite get finished. I'm going to just reset that timer. I'm finishing up option C, so I'm going to go ahead and put 2 minutes back on the clock. If you did have enough time, you can just sit tight and make sure you have those POCOs and explanations triple checked. Make sure you have all of your answers correctly explained on your paper. right, here's my thinking. That one took me longer than I had anticipated, so sorry if you found yourself with extra time there. The most important thing I would say, first of all, my answers are B, C, and D. So if you got those, awesome. If you didn't, pay extra careful attention so you'll be successful in your independent practice. The thing I think is the most helpful here is anytime you see subtraction, make it plus a negative, plus the opposite. That just helps you, once you do that and you combine the like terms, you'll be able to just match up and compare signs and see if they're the same or not. This question tries to trick you, like in A, once you combine the like terms 2n and 2n, you get 4n plus 3r plus negative 6. It's really close to the original expression, which is right here, but this term, the 3r, has the wrong sign. It should be negative 3r because originally that 3r was being subtracted. So be super careful as you're checking there. My strategy overall was to take the answer choices and simplify them by combining like terms, and then compare that back to my original expression or the one with addition. When I did that, I found that B, C, and D were all correct. If you want to look more in depth at any of these, go ahead and click pause now so you can look at the work that I did here. If not, and if you're ready to go, let's see, my answers were B, C, and D. You are ready for your independent practice. A few really important reminders. Keep watching. First, independent practice is due tonight, April 6th at 10 p.m. Make sure it is done in Illuminate. Make sure go into Google Classroom and write a private comment that says a 1 to 2 sentence lesson summary. What's something important you're taking away from this lesson into your independent practice? And lastly, when you're done with both of those things, can you please mark your Google Classroom assignment as done? So click the button that says mark as done. If it asks you to upload any work, or are you sure you didn't attach any Google Doc, that's totally fine. Your work is in Illuminate and on your notes, so don't worry about attaching any work. If you mark it as done, Ms. Russell and I are better able to know when your work is done, and we can grade it and get it back to you faster. So thank you for doing that. If you want some help on your independent practice assignment, please go to office hours at 3:15 today. And please remember to check your Google Classroom around 10 o'clock tomorrow to see if you are invited to reteach. I think that's it for me. One day, on TED Talk, I will see you for my regularly scheduled TED Talk tomorrow. Bye.